We were looking at this question related to the goods market model. In the first part, we were asked to find equilibrium level of output. In the second part, we looked at how do we graph the equilibrium level of output in the goods market diagram. Now, part C is about finding some multipliers. For this, let's recall something. In the context of chapter 3, so in the context of chapter 3, multiplier tells us how much equilibrium output changes due to a 1 unit change in due to a 1 unit change in autonomous spending. By autonomous spending, you mean spending not related to output. Spending and autonomous spending, you mean spending not related to output. Not related to output or income. Why? So we know this, right? Remember, multiplier tells us how much equilibrium output changes, right? So now from part A, we already found this, that from part A, we know equilibrium by y star is equal to 1 by 1 minus C1. So this is something we found in part A, C0 minus C1 T bar plus I bar plus G bar, right? So this is equilibrium y that we found in part A. Now, depending upon what component of autonomous spending changes, we can have government spending multiply, investment multiply, autonomous consumption multiply, and so on. So the first part asks us to find government spending multiplier. So government spending multiplier would essentially tell us how much equilibrium output changes due to 1 unit change in government spending, i.e. G bar, right? So the government spending multiplier is just partial y star by partial G bar. So we just take the derivative of this with respect to G bar, and when we take the derivative with respect to G bar, this becomes 1 by 1 minus C1. What is the interpretation of this? The interpretation of this is, like we said, the government spending multiply tells us how much equilibrium output changes due to 1 unit change in government spending. So it tells us Y star, which is equilibrium Y increases by 1 by 1 minus C1 units when G bar increases by 1 unit. So this is a government spending multiplier. What if we wanted to find the X multiplier instead? So like we said, the X multiplier would tell us how much equilibrium output changes due to 1 unit change in autonomous X's T bar, right? So the X multiplier in part 2 is going to be, so the X multiplier would be simply partial Y star by partial T bar, which is just going to be equal to minus C1 by 1 minus C1. So if we want to find the investment multiplier would tell us how much equilibrium output changes due to 1 unit change in autonomous investment, which is I bar. So it will just be partial Y star by partial I bar is equal to 1 by 1 minus C1. So in this case, we can find multipliers in chapter 3. Now, let's do the next part. Now it's the part D. So, now part D says that, okay, so now let's look at part D. Now, part D basically says, right, so for part D, we need to keep in mind, part D tells us that the government wants to increase equilibrium by 200, what change in G would be required? So now, to do part D, so now we know, okay, for this, like we just discussed, the multiplier tells us how much equilibrium output changes due to 1 unit change in autonomous spending. So we can use the multiplier. To relate changes in equilibrium y and autonomous spending, right? Because we know the multiplier tells us how much equilibrium output changes due to 1 unit change in autonomous spending. So we can use the multiplier to relate changes in equilibrium y and autonomous spending. What we're saying is that change in equilibrium y, which is y star, is equal to the multiplier times change in autonomous spending, right? Because multiplier tells you, okay, if autonomous spending changes by 1 unit, the change in equilibrium y. So if autonomous spending changes by delta A, then it will tell you what delta y star is, right? Multiplier times change in autonomous spending, right? So change in equilibrium is multiply times change in autonomous spending. So this is key to keep in mind, right? It is telling us how much equilibrium output changes due to 1 unit change in autonomous spending. So if you multiply the multiplier with the change in autonomous spending, we'll get the change in equilibrium by y star. So now obviously over here, if autonomous investment changes, we'll use investment multiplier. If government spending changes, we'll use the government spending multiplier. So now we know the government spending. Here we want to see the change in G required. So we know the government spending multiplier is 1 by 1 minus C1. Now since C1 is 0.6, it's given to us. Since C1 is 0.6, this is where we're given this. Since C1 is 0.6, so government spending multiplier is 1 by 1 minus 0.6 is 2.5. Then as change in y star is equal to 2.5 times delta G bar is equal to 300, right? The change in y star that is required is is 200. So this is 200. If this is 200, so then from here we can see that delta G bar is just going to be 200 divided by 2.5, which is going to be 80. So what does this 80 mean? This means that increase G by 80, so that to increase y star by, so this basically means increase G, which is our G bar, increase G by 80 units to increase y star by 200 units. Now, since any change in G will set a multiplier process in motion, the increase in G will be less than the required increase in Y, right? You know, because of the multiplier, you just need to increase G by 80 units to increase Y star by 200 units. Now, they're saying that if G could not be changed, how should T change to increase equilibrium Y by 200, right? So instead of the government spending multiplier, because you want to see the change in equilibrium Y star due to change in your Texas, autonomous Texas, lump sum Texas T bar. So we'll use the Tex multiplier here that we found in part C as well. So now we know the Tex multiplier is, so we know the Tex multiplier is minus C1 by 1 minus C1. Now, since C1 is 0.6, this is given to us, the Tex multiplier would be minus 0.61 minus 0.6 is minus 1.5. Alright, so this is our Tex multiplier, and we know, so now once you have a Tex multiplier, then as delta y star is equal to the multiplier, which is minus 1.5 times, times delta t bar. So it's delta, because we're using delta t bar here, we're using the Tex multiplication, we're using delta g bar, so we're using the government spending multiplier. So we know this has to be equal to 300, right? Sorry, no, this has to be, 200. So we want to change equilibrium y by 200. Then from here, we can see that delta t bar is just equal to minus, my bad, is equal to minus 200 divided by 1.5, right? So this will turn out to be minus 133.33. So this means you decrease t by, so what this is, the minus sign is there, which is telling you the directional change gets decreased, right? There it was a positive, and you are finding delta g bar, that was plus 80, right? So we said increase G by 80 units to increase Y star by 200 units. Here, because it's negative, so what we're saying is to decrease T by 133.33 units to increase Y star by 200. Again, because of the multiply process, the change in T bar that is required is less than the change in Y star that you want to achieve. So just keep in mind the multiplier tells us how much equilibrium output changes due to one unit change in autonomous spending. And we can use the multiplier to relate changes in equilibrium output and autonomous spending, where we can say the change in equilibrium Y is multiplier times change in autonomous spending.